Thank you. Hello, everyone. My name is Abhinav Tiwari, and I'm heading the Advanced Planning Group at Alectra Utilities. Um, Today's discussion will be around blockchain in energy sector and how this technology has been transforming our industry, and especially some of the prestigious initiatives we are doing at Alectra. But just before I start talking about blockchain and what we are doing here, I would like to take a step back and really reflect on whenever we assess a technology, and specifically, I will talk about myself. I have been in this digital transformation space for more than 15 years now and navigated large organizations across different industries, financial services, retail, healthcare, and so on and so forth, through their digital transformations and analytical journeys. What I have seen is whenever a new technology comes, oftentimes it starts with a hype, and that's where we say, okay, is this technology really good? Is this really going to solve my problem? And then once that hype is over, we actually see some of the real implementations, and we say, okay, whether this technology was good enough to prove what it was claiming initially, or it was more of an hype. And this goes back to my days when I was assessing big data technologies back in 2008 and 9, and then over to cloud around 2010-11 timeframe. And now with blockchain, when I was getting more familiar with it during the 2015-16 timeframe, and then when Hyperledger Fabric launched, I was asking these two questions throughout my career and journey about any new technology. One, whether what this technology can solve for me and what it can do for me. And then secondly, can it actually scale? And that second point is really important to understand when we talk about large transformations or digital technologies, which are going to be rolled out at enterprise scale. It's very, very important for us to answer that second question, because first question, typically what it can do as soon as a technology emerges, you see all these use cases floating around different industries. But the second question is more important, because if it doesn't scale, it will not go beyond a pilot or a prototype. So without further ado, I will take a step back and take a pause on blockchain, and I'll catch up later on this. Let me first talk about what my team is doing and what Alectra is. So for those, Alectra is the second largest municipally owned utility or local distribution company for electricity in North America. In Canada, if you talk about municipally owned, we are number one. We serve over 1 million customer base. In people terms, it could be 3 to 4 million, considering 3 to 4 household members, as well as institutional members. We have two major verticals. One is the Alectra Utilities, which is the LDC, or the electricity distribution part of it. And then the second one is Energy Solutions, which is the competitive side of the world, where we figure out innovative solutions in energy services space. My team is Advanced Planning Group, which actually caters to both, and we are lucky enough to figure out how we can not only advance our utility side and address some of the problems and make it more innovative, while we also create business opportunities on the innovative and competitive side of the business. I would like to take a minute and talk about really why all this blockchain and what all Alectra has been doing in this space, and why it all happened at the first place. So today, as we see around us, there are a lot of forces, or I would call them driving forces, such as our desire to shift towards renewable energy sources, because we do want to fight against the climate change which is happening around us. We are also seeing a change in consumption behavior. We all have smart thermostats, electric vehicles kind of devices in our house or around us among our friend circles. We are seeing how easy it has become, how consumer-driven industries have become, and pretty much everything is accessible through your mobile phone or through an automated gadget. On the other hand, we are also seeing electrification of transportation. You see electric vehicles all around us. At the same time, there are lots of efforts happening around transportation being electrified, which is again is a changing or driving force. And then among all of this, what we as customers of electricity, we want is not our electricity prices to increase. We want them to go down. All of us want that. So among all these driving forces, now we see on the other hand, a lot of changes happening either on the price reduction on the solar side or the batteries. And because of all that changes, we are seeing the proliferation or the dominance of these distributed energy resources. And by the way, this is a broad category for those who are not from utility sector. Distributed energy resources are a broad category for devices such as solar panels, wind turbines, all these renewable devices, or energy storage devices, or electric vehicles for that matter. Even your smart thermostat falls under that category. So when we see adoption of these devices or proliferation in the industry, on the other hand, we have all these goals, which I spoke earlier. Combined together, it is not an easy problem to solve. There are lots of challenges. And those challenges actually are there from the transmission level, where the energy is transmitted from the generation source to local substations. And then from the distribution companies like Alectra's perspective, we have to make sure reliable electricity transmission to households and industrial and commercial premises. So it's not an easy problem to solve, where we want to keep the prices low while accommodate all these devices into the network and address the climate change problem at the same time. So not only transmission operators, but also distribution operators, as well as regulators, such as in Ontario, we have Ontario Electricity Energy Board. They are also looking into ways to do things differently, how they are done today. So let me take a minute more on how what exactly the problems I'm talking about. A simple example which I often talk about is an electric vehicle when plugged in the evening, when somebody comes home from their office and they plug in the vehicle at 6 p.m. Due to the high amount of, if the vehicle is being charged at full rate, due to the high amount of power it takes, although it takes for a few hours, if it's a supercharger, maybe 2 hours, 3 hours, but during those 2-3 hours, if the vehicle has to be fully charged, it takes an amount of power which is equivalent to 2 to 2.5 times of a household load. And imagine these 10 of electric vehicles under the same distribution transformer, how much load are we increasing without even telling the utility? So a utility needs to know how these loads are increasing in the network. So when we look at from Alectra's point of view or distribution utility point of view, we have to make sure that all these energy resources, and here I just covered an electric vehicle example. Imagine solar batteries, solar panels, and battery storages, as well as in large commercial spaces around wind turbines. You think about all these resources generating energy without even telling the utility, or consuming energy without even telling the utility, the kind of instability it can cause to the network. And this I'm, by the way, talking only at the distribution transformer level. Now aggregate all this problem to a substation level, where you have so many feeders and distribution transformers, and we have to address that problem. At the transmission operator level, this problem even becomes bigger. In Ontario itself, we have 60 utility companies like Alectra. Imagine a transmission system who is seeing 60 utility companies at the same time at an aggregated level. What kind of scale of problems are we talking in terms of instability of the network if a lot of electric vehicles and a lot of solar panels suddenly appear out of nowhere and they start either pulling a lot of energy from the grid or giving it back to the grid. To solve that problem, what utility companies are looking at, creating a platform which can actually allow me and you as utility consumers or providers. So if I have a electric vehicle and I have a solar panel, there is a good chance that my solar panel in a bright sunny day will generate more energy, surplus energy sometimes, which I may not need. Now what to do with that? Either I store it in a battery, so I need a lot of battery storage capacity, and if that energy is even more than the battery storage, it will be unused. So why not create a platform which can allow me to send back the surplus energy back to the grid, which can be used by some other user in the network? Now, this sounds very simple. This is not an easy problem to solve. I mean, think about all those poles and wires who are feeding energy in one way. Now, suddenly you see energy going in the other way around. It's not an easy problem to solve, because the capacity of those transformers, the energy being supplied, all of that is from a perspective that a certain amount of load is there. Now, if that load has decreased, now we have the surplus energy, what to do with that? And not only that, surplus energy is being fed to the grid, less energy is being consumed. So now we have surplus energy at the generation. And so this problem at a large scale becomes a serious problem. And hence we need a platform which can enable two-way communication of not just the energy, but if as a consumer, I'm using energy, I'm paying bills. Now, when I give energy back to the grid from my solar panel, I would expect a return of some dollars. So what Alectra has done, we have built a platform which allows not only to consume energy from the grid, but also sell it back to the grid. And that platform will also facilitate, dollar transactions to and fro. So based on my energy, net energy consumption, if it's net consumption is positive, I have to pay the bill. If net consumption is negative, which means I'm giving back to the grid more than what I'm consuming, then I will earn some dollars. So in surplus, and I won't have to pay the bill. So that kind of platform, and again, not everything is in Alectra's control because there is a regulatory body which says, which has set certain rules. So we have to go by the rules. But at least the platform or technological infrastructure has to be there. When the rules get changed, we should be prepared for that change. So before I talk about what Alectra has built, let me take a minute to talk about the blockchain technology. And as I said in the beginning, I often ask these two questions. One is what this technology can do for me, and second, whether it can scale. So when we were assessing blockchain, there are different flavors of blockchain, as we all know. We have, on one hand, we have public blockchains. We hear all these use cases around Bitcoins, Ethereums, so many other cryptocurrencies and coins. The challenge with public blockchain technology is it is computationally very expensive, and scalability is a big problem there. Because of computational expensive nature of it, scalability is also a problem, and to build a network of nodes and infrastructure is a very expensive affair. The second type of blockchain is the private blockchain, which actually is designed, and a good example for private blockchain are Hyperledger Fabric, Linux Foundation's Sawtooth project. And what it really brings is you can now use the same good features of blockchain, that openness, the trust, the shared ledger, and smart contracting features. At the same time, you have a capability to keep this within a closed network. In an electricity network, it's very, very important. You don't want, as a customer, for anybody in the world to see what kind of transactions are happening in the network. You really want that trust factor to be maintained with the utility. However, you do want to see how much I paid back, how much energy I gave back to the grid, and how much I received from the grid at any point in time. And then you want to see dollars as against to those. So blockchain technology can provide that openness, yet keep it private within the network. And then there are federated and hybrid blockchains. Why I'm explaining all these blockchains technologies, where federated talks about the same private network now being managed by multiple organizations, quite similar to the private in other sense. But the hybrid one is more a mix of where certain data could be made public, like in a public blockchain, and certain could be made private. Now, what we did is we took the good features out of all these, and we really built a blockchain network where we keep it private. We have it permissioned so that any party who is joining the network cannot just join like a public blockchain. They have to have a permission of the whole network. And then all the parties involved in the network can see each other's transaction. Now, this is a perfect time to move to the next slide and talk about the solution and give you a real example which can show you how blockchain is being used. So here is our grid exchange platform. Now, what we have done is the same transactive energy concept, which I just explained in terms of how a consumer like me, having installed a solar panel and a battery, can now feed back surplus energy back to the grid and earn dollars against it. Now take that same concept, and we have put blockchain as a foundational layer, and there are lots of complex layers on top of it, which are doing analytics and a lot of other transactions. But in the end, what is enabled is an end user now is connected to its utility, such as Alectra. So now Abhinav as an end user is connected to Alectra and can take energy and also give it back to the grid. And now Alectra as a whole can take energies from Abhinav and similar users, aggregate it, and now give it back to a market operator party like ISOs in Ontario. So what ISO will make sure now, it will not generate that much energy, which it had to initially if there were no distributed resources like these, and it will generate less, and it will maintain that demand supply curve. That's the prime goal of ISO, where they always try to maintain this demand supply curve. Now, in a transaction like this, if Abhinav has a surplus energy in this case, and if there is a way I can give back to the grid, that's where the key feature of blockchain is enabled. So right from the procurement of this energy, so when Alectra says, Abhinav, yeah, I allow you to give energy back to the grid, right from the procurement of the service to the selection of customers, then from procurement to the actual energy delivery, where that particular day and time comes, where Abhinav says, Abhinav promised initially that, yes, I'm going to give energy back to the grid for those 1 or 2 hours, whatever they are. That is the delivery part. And now taking that delivery part to the settlement part, where Alectra says, okay, with respect to your contribution of energy, I'm going to pay you dollars. All of this transaction is now recorded on blockchain. So from procurement to contracting between Abhinav and Alectra, to the verification that Abhinav actually gave the service, what he promised, and then the settlement that Abhinav can make sure that, yeah, whatever energy I provided, I got the dollar with respect to that, and there was no miscalculation in the amount of dollars. All that is enabled on blockchain, and all the parties, including the end customer like Abhinav, myself, the Alectra, and then ISO like a transmission operator, can actually see this, that who provided what energy and at what date and time, and how much they were rewarded against. So to enable all of this sounds very simple, but it comes with a lot of problems at the distribution. Foremost problem is there is no distribution market today. All we have is a wholesale market. As I spoke about ISO, who manages the demand supply curve at any point in time at the transmission level and make sure certain generators are allowed to feed back energy or not, or certain generators are turned on or off. There is no such market at the distribution level, like at the level where our LDCs are or Electra-like companies are. So our approach is one step towards providing that infrastructure to create such a market where actually these end consumers can be allowed to participate with their energy and then given rewards back and make them really more resilient. Now, with respect to this blockchain platform, what we have enabled are 3 services, and these 3 are selected. These 3 services are selected with a very important goal in mind. One is to help distribution companies. As I said, when an electric vehicle gets plugged in, it puts so much load on the distribution transformer, and when at scale, these electric vehicles can create distribution level problem, and you see that peak every evening. If 10 of the EV customers under the same transformers are all returning 5 to 6 p.m. in the evening, you see that peak of between 5 to 7 p.m. or 8 p.m. of energy being drawn from the transformer, which it was not maybe prepared for, you may see an outage. And to prevent that, we call that phenomena as peak shaving. So to do peak shaving, we really want to manage the electric vehicle charging. So if a customer like me who has an electric vehicle plugs in and Alectra says, you know what, I can pay you, if you don't have to go anywhere in the evening, I can pay you dollars. If you let me control the charging rate of your vehicle, I will not charge it at 100%. You select the rate. So in our application, a user can actually select the rate of charge and make the charging rate 50%, and Alectra will pay the user dollars against that behavior. The other service is the GHG reduction. So when the generation source is emitting more carbon, we signal our consumers that, hey, if you not use energy from the grid at this time, when the generating source will be emitting a lot of carbon and greenhouse gases, we will pay you for that behavior. So if they are not using energy from the grid, we will pay them for that. And the third is the demand response. If Electra-like utility says to its customers, do not use energy between certain time period from the grid and we will pay you for that, that's the demand response service, which is like either don't use it or give it back to the grid. So what we are launching in this pilot phase is we are launching these services with some selected customers in our service territory within Alectra, and we will be launching these 3 services, which will allow customers with their mobile phone apps to actually participate in these services. In the end, what it will bring not just benefits to the end customers, which I explained, of course, customers can earn dollars. It will also give them more reliability. So if there is an outage coming, this application will notify the customers that, hey, do not use energy, do not provide it back to the grid, or do not use it, save it in your battery, because then you can use it when there is an outage coming, because we know there is a weather related problem happening, or weather is going to be bad, you may have an outage. So that way, a trust between utility and the customer increases. And of course, customers save dollars and then get incentives while participating in these kind of services. It also helps reduce the carbon footprint for our overall environment. What it brings to LDCs like Alectra and ISO is really more visibility over their network. So now Alectra will know which customers have these distributed energy resources, which can not only consume from the grid, such as electric vehicles, but can also give it back to the grid, such as solar panels. So with this visibility, now Alectra can plan how much capacity to increase in a distribution transformer, how to install a substation eventually or not, because now you have so many DERs. For ISO, which is playing at the transmission level, it solves even a bigger problem. Now ISO has more visibility through Alectra and other utilities that how much distributed generation capacity they have, and now they can use that towards their planning process and actually not turn on a generator or turn on a generator depending upon the need. A lot of technology players are also joining this, are also interested in joining this platform. And we have a long list right now where we are in conversations with them. Some of them are already part of this platform, where they are interested in getting into this platform with a motive of improving their platform itself, their technology itself. So as we talk about all the machine learning, artificial intelligence related techniques, these models are built based on data's learning. The more the data, the better is the learning most of the time, depending upon the quality of the data. And then in this case, because grid exchange is touching so many customers and so many partners are involved, there'll be lots of data to help them improve their own platform and not only improve their technology, but also generate a lot of revenue. So it's a win-win for all of us, and we are quite ambitious. And this is one of its platform which there have been many transactive energy efforts throughout the globe. Some have been prototypes, some have been some pilots, but I think it's one of its unique, which is built on blockchain. And it also proves the capability of blockchain, that it's not just an hype, it's actually a technology which we can use and use it very effectively to build that trust, which may get lost if we build this scale of a platform. So thanks to blockchain and thanks to our team who are working tirelessly over past more than a year now. And we are about to roll this platform in a month or so. So thank you. That's all I have today. And I'm opening up to any questions you have for me and happy to answer those.
Thank you, Abhinav, for a great presentation. We're always, I think, interested in hearing about how blockchain is implemented, and especially in the energy sector. We did receive a few questions. I'm going to merge a couple of them together because they're similar. And it would be, is blockchain considered a more secure approach? And if there are risks, what are the risks associated with the technology?
A very good question. So blockchain does solve some of the issues related to data security. Having said that, there are technologies apart from blockchain out there which are as secure as a blockchain. Why we use blockchain is a very important point here, is it increases the trust factor. There is no one party, and when I'll go back to one of the slides, which I actually my mobile phone as a user, that yes, I want the Alectra or a utility to control my electric vehicle charging rate. That click of on the mobile phone is actually written on the blockchain. So on the top left, if you see residential customers, they are connected to the blockchain layer. So a user cannot later on deny that, oh, I did not do that. I don't know what the platform does. Today in our banking applications, we come across this problem a lot of times where we have to reverse a transaction and somebody can hack the system. In blockchain, hacking is not possible, or it's not easy, I would say, because of its inherent nature. Everybody who is part of that transaction is actually doing a bit in pieces of that transaction. So if Alectra says, I paid you this dollar, it gets written to the blockchain. And this very nature of writing to the blockchain, which is shared between all these parties in a transaction, is actually enabling that trust, which no other technology brings in. And that's what is important to know here, that how blockchain distinguishes itself from other technologies which have been out there and more mature, but blockchain distinguishes because of this very nature of enabling trust through transparency.
Awesome. Well, Abhinav, thank you so much. If people can reach out to you directly for any additional questions, that would be great if you're sticking around.
Absolutely. Yeah, I'm
Great.
around.
Thank you. Have a good one.
Thank you so much.